We've got water problems all across the state of Texas, and there's lakes and reservoirs dried up. Water is the #1 issue for everybody, for people living in cities as well as the people involved in agriculture.
Population here in the Rio Grande Valley is going to keep increasing. And we have to think of water as a resource that right now we might have it, but tomorrow we might not have it.
The rate that the Rio Grande Valley is growing, municipalities are going to require much more water. There's going to be a lot of pressure on the agricultural community to better utilize the water, and in some cases, their water rights may be taken away or reduced.
Agriculture uses a great deal of water in Texas for the production of agricultural products. And so we have to find ways to be more efficient and to be able to irrigate our farmers' lands with less water than we've had in the past.
The Harlingen Irrigation District back in the early 50s and 60s put 160 miles or so of canals into pipelines that feed the 40,000 acres that we irrigate.
That was a major issue for this district and has allowed us to continue to grow efficiently with our water delivery system.
In Texas today, agriculture uses 60% of the available water resources, and in the Rio Grande Valley, agriculture holds 90% of the surface water rights. As population in the valley continues to grow, it has put a greater strain on water resources. That's why in 2004, the Harlingen Irrigation District received a grant from the Texas Water Development Board to begin the Texas Project for Ag Water Efficiency.
We really hope that we could find some ways to help the farmer to be more efficient in his irrigation.
The project recruited farmers in the valley for real-world irrigation studies. On-farm results clearly demonstrate that traditional irrigation methods can be modified to more efficiently deliver water where the plant can utilize it and ultimately reduce ag water demand.
I started farming here in about 1968. We did go through some drought periods back in the early 2000s, and water use was restricted. A lot of people that were doing flood irrigation actually ran out of irrigation water. We use perhaps less than half the amount of water on a drip system as you would on a normal flood system. I had very extremely good yields during that period when other people suffered because of lack of water.
Citrus is an important cash crop in the valley, so the Harlingen Irrigation District has partnered with the Texas A&M University at Kingsville Citrus Center to explore ways to grow citrus crops with less water.
Citrus is different from many other crops. All year round you have to irrigate citrus. The average rainfall here in the valley is 23 inches, and it takes 48 inches to sustain citrus production. So there's a big gap. If we can channel water more efficiently to areas that are needed, that also will prevent certain diseases like bacteria, fungus, or even insects, to proliferate in your crop.
This partnership has resulted in the development of a low-cost irrigation technique that has shown significant results.
Another practice that we implement in the citrus industry is the use of narrow border flood irrigation. We form a raised bed on the side of the citrus tree, and we do that between every citrus row where water can move down where the citrus tree roots are growing. The great thing about this, we found that we can save up to 35% water just by this simple management practice that can be implemented now.
The Rio Grande Center for Ag Water Efficiency is a state-of-the-art facility designed to showcase the project's findings.
We built this facility as a training and demonstration center to help other irrigation districts and farmers realize the potential of conservation in the Rio Grande Valley. The methods and technologies we teach here are relatively new to the growers in the Rio Grande Valley. For the grower, we teach soil moisture monitoring. how the devices are installed, how to manage the device, and how to better manage their on-farm delivery using the meters that we demonstrate here, as well as demonstration of soil moisture devices.
We're looking at a telemetry system that looks at some of the soil moisture monitoring that's going on inside the citrus root zone, see how much water is being taken up from the roots and when we need to irrigate. And they send information to the telemetry system that ends up sending a signal back to Jim Hoffman's office, where he can look at the data in real time, and then he can make decisions of when he needs to irrigate the trees.
If you did not have some way to measure the amount of moisture in the soil and how fast it was being depleted, you might over-apply water or you might under-apply water.
We had a 3-inch rain event here a while back, and less than 10 days later this place needed water. You know, and the sensors told me that. We had half of the property being watered that afternoon.
Well, hopefully the results of our project has demonstrated that if you can reduce your cost of water, you've got to be affecting your bottom line, your profitability.
Along with demonstrating on-farm practices, the project also shows districts how to improve their system-wide efficiency.
The reality is most of the irrigation waste is in the delivery systems. So it's important for us to demonstrate to the districts how important their delivery system is to helping the farmer be efficient.
Harlingen's telemetry system uses wind and solar power throughout the canal system and is a model of district automation, connecting water level sensors and automated gates with district staff 24/7.
As the Rio Grande Valley moves towards metering, this is a facility we can use to test, calibrate, and build confidence in the meters. We measure what we put in, we measure what we take out, and we can determine how efficient we are at delivering that water to the grower. This automated gate is actually the prototype to the gates that we've installed throughout the district. We use this primarily for training irrigation district managers and staff. They can understand how their canals are going to work when it's automated.
Hands-on training in automation and new technology is important for district personnel.
The canal operator is responsible for the delivery to the water for the farmers, responsible for the city to supply them with water. When I first started, everything was manual. In fact, we didn't even have cell phones. We had pagers.
The old process of manual gate operation was inefficient, slow, and could delay water delivery to farms.
Now, everything is on the computer system. We set our water at night, and the computer will do the trimming to keep our canals full. If for some odd reason a canal goes low, we have alerts set up that gives us a call no matter what time it is. If it's something major that I can tell that's not right, I go out and check it. If not, okay, it's just because I made a bad adjustment and it's fixed. The farmer can rely on that water to stay constant. They don't have to worry about it. I've seen a great improvement from when I first started to now.
We have a lot of hope for agriculture in this valley. The growers are very optimistic about having water. The rains do come. We're committed as a group for the preservation of agriculture, the promotion of water conservation issues, so we're constantly communicating.
We're getting the information together so when it comes this time, we'll be prepared. If we're not prepared, then we'll be behind. This farming community will just die.
So what we need to strive for is how can we use that gallon of water the most efficiently to provide the irrigation that our crops need and provide the income that our community needs to continue as we are.
As Texas looks to its water future, all eyes are on agriculture. It's time for Texas to invest in efficient water infrastructure and technology on farm and in district.
I think water costs are going to double, if not triple, in the next 10 to 15 years. So I think it's essential that everybody really begin conserving water now and not wait until it really gets crunch time.
Once people start going into other water managing practices, then maybe those things will catch on with future generations. It's an uphill battle, and but we can push and we can try.
With the new technology and education that we're receiving, we can improve the techniques, the methods that we use, how we water our crops, how we water our lawns. It's not just agriculture, but it's also everybody that benefits from agriculture.
I hope that the information that comes out of this project can be delivered to those legislators, those policymakers, that when they start making rulings on how we deliver our water and who has the right to that water, they take into account the importance of that irrigation water to the Rio Grande Valley.
We in agriculture need to be aggressive in our efforts to put out information and educate folks as to what agriculture does and how important the water is to our agricultural community and to the economy of the state.
To learn more about the Texas Project for Ag Water Efficiency, visit texasawe.org.